All right. You're welcome once again to the JAM chemistry syllabus teachings. And this is going to be one out of a series of topics that I'm going to be treating based on the chemistry JAM syllabus. And we are looking at the very first topic in the syllabus today. And the topic is exploring pure substances. Exploring pure substances. Just a minute. Let me quickly hide this floating meeting control, and then we'll jump back in. All right. Now, so we want to look at exploring pure substances, elements, compounds, and mixture. I'm going to be your teacher in the course of this lessons, and my name is Anjori Oluwafemi Excel. I hold a bachelor's degree in chemistry from the Premier University, University of Ibadan. I also attended Yaba College of Technology, where I obtained a national diploma, or what we call the ordinary national diploma in science laboratory technology. I also hold a postgraduate diploma in education with a focus in science education. I also studied at the Redeemers University, where I obtained my master's in environmental and analytical chemistry. And I welcome you to this teaching, and I hope that you and I will have a very wonderful time. So, like I said earlier, our topic is exploring pure substances, and we want to focus on elements, compounds, and mixture. So what's our learning objective? Let's look at our learning objective quickly. Our learning objective for this lesson is number one. By the end of this lesson, you should be able to distinguish between pure and impure substances. And secondly, you should be able to use boiling and melting point as criteria for purity of chemical substances. And equally, you should be able to distinguish between elements, compounds, and mixtures. Also, you should be able to differentiate between chemical and physical changes, and also to identify the properties of the component of a mixture. So that's our learning objective for this particular topic. And without much ado, we move into the very first slide now. Pure substances. What are they? To your own understanding, I know you might have heard this before. Someone have said, okay, what a pure substance is, so and so. To your own understanding, what do you think a pure substance is? If you have an idea, put your response in the comment section. I will react to it accordingly. Okay, all right. So we want to look at pure substances, and I will start off by defining what a pure substance is. And a pure substance basically is a substance that consists of only one type of particles or components, such as an element or compounds. So these substances cannot be separated by physical processes and exhibit consistent properties throughout. So what we are saying in a nutshell is that a pure substance is made up of just one type, only one type of particle or components. So that is what a pure substance is made up of. And we also established from this little definition that a pure substance can be separated using physical processes, and in subsequent class, we look at different separation techniques that we have, and we'll talk about them in details in the second class. So stay tuned and make sure that you're around to also view and also learn in the second class or the second video that I'll be uploading very shortly on separation processes. So pure substances, examples include elements and compounds. Elements like oxygen, gold, helium, beryllium, potassium, the list is endless. And this is an example of a pure substance. Why? It contains only one type of particle or component. Now, we also have compounds as a pure substance, so as an example of a pure substance. And examples of compounds like water, methane, and so on and so forth. So I tried using this little diagram by the right-hand side of my own screen here to differentiate between pure substance, examples of pure substance, which we have differentiated to be either element or compound. So examples of elements like tin, like diamond, these are elements, and then compounds like sugar, water, and so on and so forth. These are examples of compounds. So a pure substance consists of only one type of component or particle. They can be separated through physical processes or techniques, as the case may be. And then we have given the examples of pure substances to be either a element or compound. Okay, having said that, let's look at and understand this definition. In understanding this definition, I will have some few questions. And the first question is, how can you tell if a substance is pure or not? Based on the definition we just had now, how can you tell that a substance is pure or is not pure? If you know the answer, please put your response in the comment section and I will do justice to them by reacting appropriately. Now, the second one is, can you think of an everyday example of a pure substance? Can you think of an everyday example of a pure substance? How do you know that it is pure? Put the answer in the comment section and I will pick it up. What are some examples of pure substances in food and drinks? What are examples of pure substances in food and drink? Don't forget that example that I gave to you earlier. Some drinks contain sugar. Sugar is an example of a pure substance. So if you know other examples of pure substances in food and in drink, please put your response in the comment section and then I will respond accordingly. If you mix two substances, does it result in a pure substance? Why? Or why not? So please tell me what your answer is also in the comment section. If something is made up of only one type of atom, is it always a pure substance? Why or why not, please? Your answer, let it be in the comment section and I would respond to it accordingly. Now, I haven't gone through this process of defining what a pure substance is and going a step further by trying to know how well you understand the definition. The next slide will focus on the characteristics of pure substances. And what are some of the characteristics of pure substances? One, fixed composition. Pure substances have what we call fixed composition. They exist in fixed composition. You have example like water. You have two atoms of hydrogen bonding together with one atom of oxygen. Fixed composition. Another characteristics of pure substances is uniform properties. There is uniformity in the properties of substances that make up a pure substance. Another characteristics or properties of pure substances is that they cannot be separated by physical method. Pure substances cannot be separated by physical method. So please, let's take note of that. They cannot be separated by physical method. Just like I stated in the definition earlier, pure substances cannot be separated by physical method. You can deploy other methods to separate them, but not physical method of fractional distillation or decantation or whatsoever it is like that. So they cannot be separated by physical method. Another characteristic or properties of pure substances is that they have definite melting and boiling points. What signals out or tells us that the substance is pure is the definitive nature of their melting point and their boiling point. Water has a particular melting point. Water also have what a definite boiling point, which is 100 degrees centigrade. So definite melting and boiling point is a characteristic of properties of a pure substance. Okay, the final one is that pure substances, the density of a pure substance remain constant under fixed condition. So their density remain constant. So their density can remain under a constant under a fixed condition of maybe pressure or temperature, as the case may be. So the density of a pure substance remains constant under fixed condition. Now, this property can help distinguish pure substance from mixture. The constant nature of the density of pure substance under fixed condition is a very, very unique characteristics that can help us to distinguish between pure substances and mixtures. Okay, having said that, now let's look at an example of a pure substance. We give an example of a pure substance as elements and compounds. So we start off with elements now. Now, if you look at the box, having the colors, the different colored balls and every other thing. In that particular box, you have three items. You have elements, you have compounds, and then you have mixtures. Now, if you look at elements closely, what do you notice there? You will notice that each of the columns will have just one particular colored box, They can have them like that, just green, 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 green in the first box. The second column has just yellow balls, and then the third one has blue, although conjunct as in linked up, unlike what we have in the first and the second column, but they are all blue. They contain only one type of what? Of particle or component. Now, for compounds, you can see that yes, they may have different elements coming together to bound together to form them, just like we have example. But it is in a fixed composition. It is not adversarial in nature. It's in a fixed composition, in a definite composition. But for mixtures, you discover in the column for the mixture, you can see purple coming together with yellow, yellow coming together with blue, green coming together with green, blue coming together with just mixed up like that, No fixed composition, no definite composition whatsoever. That's an example of a mixture. We'll talk about them in subsequent slide. But let's focus now on element, which is an example of a pure substance. Now, what is an element? An element is a pure substance made up of one type of atom. It is made up of what? One type of atom. It cannot be broken down by chemical or physical means. That is an element. It consists of just what? One type of atom, and it cannot be broken down by chemical or physical means. Although there are other means that have been deployed, to break down elements, and this we'll look at as we have advanced in the course of this teaching, or in this course of this classes that we are going to be having together. Now, examples of elements include oxygen, hydrogen, gold. If you have other examples, you can also put them in the comment section, and I will respond to them appropriately. Okay, I haven't talked about elements now. Okay, this is a slide showing elements and then compounds. Now, if you look at the first row there, you have oxygen, hydrogen, nitrogen, and carbon. These are all elements. These are all examples of elements. Now, when you look at the compounds closely, you can have nitrogen oxide, in which we have nitrogen bonding together with oxygen. We can equally have water, where we have two atoms of hydrogen bonding together with oxygen. Then we can also have nitrogen dioxide, like NO2. You have two atoms of oxygen bonded together to nitrogen, and so on and so forth. These are examples of compounds. Now, let's look at compounds closely now. A compound consists of two or more different type of atoms chemically bonded together in fixed proportion. Now, let's look at some keywords in that definition. A compound will always be made up of two or more different types of atoms. So before you can have an atom, before you can have a compound being formed, it must be a combination of two or more different types of atoms. And these different types of atoms are chemically bonded. That's another keyword. They are chemically bonded in fixed proportion. In what? In fixed proportion. These are very, very important keywords that we must take note of. Two or more atoms chemically bonded together in fixed proportions. Okay? Now, compounds can only be separated by chemical methods, and their properties are different from the elements they contain. Now, what we are saying in a nutshell is that when you have nitrogen and oxygen forming nitrogen oxide or nitrogen oxide, as the case may be, now the properties of that compound that is formed is quite different from the elements that came together to form the compound. And that is what that statement is trying to establish. So what are the examples of compounds that we have? We have water as an example of a compound. And we have sodium chloride, which you call the common salt, an example of compounds, and so many other examples that we've made mention of in the previous slide. Okay, now let's move a note further and then talk about mixtures now. What are mixtures? What is a mixture, or what are mixtures as the case may be? Now, basically, a mixture is a combination of two or more substances that are not chemically bonded. Now, let's take a pause and quickly reflect on this now. Compounds. made up of what? Or consists of two or more atoms that are chemically bonded together. Notes, mixture, a combination of two or more substances that are not chemically bonded and can be separated by physical methods. Don't forget that for compounds, you can only separate them through what chemical method. I'm going to still do a comparison very soon, but I just want to establish this before I move on to the slide. I will talk about the comparison and all that. So please don't forget this. Keywords: a mixture, combination of two or more substances, and they are not chemically bonded and can be separated by physical method. Very, very important. Now, a mixture is also referred to as an impure substance. An example of mixtures includes air. Air is a composition of different types of gases. And in the course of this lesson, we are also still going to treat air as a topic. So I want you to stay glued and continue with this lesson so that you can be able to get the best, and have a robust understanding of what you are expected to have before you go and write your JAMB examination. Okay, so examples of mixtures are air, sea, salt water, soil, vegetable soup. How many of you have taken vegetable soup before? Yes. Can you tell me the composition of vegetable soup? Put it in the comment section. I will look at it. Okay. So yes, vegetable soup is. I'm from the southwestern part of Nigeria, and what we use in making vegetable soup varies actually. Those from the south part of Nigeria, from the northern part of Nigeria, and the southeastern part of Nigeria also have different vegetable soups and different component goes into it. And this is a very good example of a mixture. Vegetable soup is a very good example of a mixture. You have your vegetable leaf, you have your Maggi, you have your salt, you have your fish, dry fish as the case may be. Sometimes you want to put meat into it and all that, just mix them up together. It's a wonderful mixture. And it can be very, very delicious. Or it's not so, yeah, it can be very, very delicious when they prepare a very wonderful vegetable soup. But it's not a vegetable soup class, so let's move along now. So example of mixtures, like I said, air, salt water, soil, vegetable soup. You can give me all the examples in the comment section. Just put them in the comment section and I will react to them accordingly. So mixtures can be classified into two. Mixtures can either be homogeneous or heterogeneous mixture. A homogeneous mixture is a mixture that has what we call a uniform composition. It has a uniform composition, okay? Whereas heterogeneous mixtures have what we call non-uniform composition. That is, the components are not uniform, and that is heterogeneous mixtures. Okay, now let's look at some real-life example of homogeneous and heterogeneous mixtures. Now, for homogeneous mixtures, we have an example like coffee. It's homogeneous because all the components will blend in together and they become what one, so to speak, clear, and it's indistinguishable. We can't even know that, oh, this is what was put in and all that, because everything just blends in together and it makes a perfect mixture. So coffee is an example of an homogeneous mixture. Steel is also an example of homogeneous mixture because the components will be subjected to high temperature and it melts them up together at high temperature, and the resulting product is homogeneous because all the other components will have fused in perfectly. So we have an homogeneous product that will come forth. So steel is an example of homogeneous mixture. An example of heterogeneous mixture is pizza. How many of us have eaten pizza before? Yes. How many of us know how to prepare pizza? Okay, so pizza is an example of homogeneous or heterogeneous mixture. You have different things that goes into making of your pizza. Your cheese will go in, your dough, your flour will go in. Some people will put other toppings, different things, vegetables and all that some people will put in to make a pizza, depending on the type of pizza that you are making and all that. Everything just fusing together. But what you end up having is an heterogeneous mixture in which the composition that makes up that pizza is not uniform. Another example of a heterogeneous mixture is something that most of us like eating so much, chocolate chip cookies. If I ask that how many of us have eaten this together, I know so many reactions will come in this regard. So This is an example of heterogeneous mixture. Chocolate chip cookies is an example of heterogeneous mixture also. And the reason is because the composition are not uniform. They are not uniform. Okay. All right. Having said this, let's quickly do a comparison between these three components now. The component that we are comparing is we are comparing based on certain property, we want to look at key difference between elements, compounds, and then mixtures also. Now, when you look at composition, in terms of composition, elements are made up of only one type of atom. Now, in terms of composition, compounds are made up of two or more types of atoms that are chemically bonded together. In terms of composition, also, mixtures are made up of two or more substances that are mixed together, but they are not chemically bonded anyway. Now, in terms of separation, the element can be separated by, cannot be separated, please, cannot be separated by physical methods. Compounds can only be separated by chemical methods, and then mixtures can be separated by physical methods. So please, let's take note of this. In terms of their properties, elements have what we call unique. They are unique and they have fixed properties. Compounds, on the other hand, are different from their elements, and that is there's a peculiarity in their composition. So the fact that nitrogen and oxygen combine to give us nitrogen four oxide, nitrogen dioxide, does not mean that the properties of nitrogen dioxide will be similar to the property of nitrogen and then the property of oxygen. So when the atoms come together and they bond together, they still have this ability to be different in their properties from the compound that was formed from them. So please, let's take note of this. But mixtures on the other hand, the components retain their properties. They have their individual properties and they retain them in the mixtures. Okay, so we've talked about examples before, examples of elements, examples of compounds, and examples of mixtures. Then the proportion of components is another thing that we can use as a yardstick to differentiate between elements and compounds and mixtures. So for elements, they have fixed composition, only one element. Then for compound, fixed ratio of elements, just like we talked about hydrogen and oxygen in the ratio 2 to 1, two hydrogen and one oxygen to make up water. So fixed ratio of elements. And then for mixtures, components can vary in proportion. So these are the key differences, and please make sure that you have a clear understanding of this so that if questions comes out in this regard, you'll be able to respond accordingly. All right, now let me do and show you a schematic of pure substances and mixtures now. So all that I've been talking about for so far, or I've been discussing so far, we can just use this diagram or the schematics to explain or to concretize knowledge. Substances can either be pure substance or impure substance. Examples of pure substance, like we talked about before, are elements and compounds. Examples of elements, you have the metal, the non-metal, the metalloid, the noble gases, and so on and so forth, like that. For impure substance, a very close example is the mixtures. And mixtures can either be homogeneous or heterogeneous. All right. See, okay. Now, let's look at the final thing before I summarize this lesson and then evaluate the lesson accordingly. We want to differentiate between physical and chemical changes. Physical and chemical changes. Now, what is a physical change? A physical change is one that in which no new substance is formed. A change that occurs in which no new substance is formed is called a physical change. A physical change is a change in which the products of the change cannot be reversed. They are not reversible. Often they are not reversible. So I'll give examples to buttress this definition I've just given now. Now, chemical change on the other hand is a change that occurs in which new substances are formed. Not only that, chemical change are usually, sorry, please, I think I mixed up something. Let me go back to physical change again and explain it all over again. Now, a physical change is one that occurs in which no new substance or substances are formed, as the case may be. So no new substance is formed with a physical change, and then they are often reversible. Yes, that's what I need to stress. Physical change or changes are often reversible. So you can get that, you can get back the initial thing that you changed to another thing. You can get it back after a while. So they are often reversible. Now, for chemical change, new substance or substances are formed. That's for a chemical change. Now, for a chemical change also, it is usually irreversible. You can't redeem that which had been changed in chemical change. And that's a clear difference between physical and chemical change. One, no new substance is formed. The other one, new substance is formed. The physical change, it is often reversible. Chemical change, usually irreversible. So these are the differences between, or the difference between physical and chemical changes. Now, let's take it a notch further and look at examples of these changes. Now, for physical change, you have example like melting ice. And that was why I told you that, well, no new substance are really formed, and then it is reversible. Melting ice is just water taken from liquid state to solid state. Now, what happens is that if you leave that water after a while, that ice block water that becomes solid, frozen solid, it melts. And when it melts, what does it give us back? Water. Water. So these are the example of a physical change. Example of a physical change is boiling water. No new substance is formed, and then the original substance can still be reversed and be gotten back. Now, cutting diamond, crushing a pencil, these are examples of physical changes. Now, chemical change on the other hand, like rusting iron, burning wood, burning of paper. These are examples of chemical change. When you burn wood or burn paper, let's say wood, when you burn wood, you end up having charcoal. You cannot get the wood back. It's a new substance, an entirely new substance that is formed. When you burn paper, you end up having paper hash or hash, as the case may be, or hashes, as the case may be. You can't get the paper back, so it is not reversible. So these are examples of a chemical change and excuse me, examples of physical change. Okay. Having said that, you can also give me more examples that you know of physical and chemical change in the comment section, and I will respond accordingly to them. All right. Now, so let's summarize this lesson. In the course of teaching, we talked about pure substances and we said pure substances are elements, examples are elements and compounds. We define what a pure substance is. We define what an element is. We gave examples to the effects. We define what compounds are, and we also gave examples of compounds. We also touched on mixtures, and we defined what mixtures are. And we classified mixture to either be homogeneous and heterogeneous. And we did not stop there. We equally looked at key differences between element compounds and then mixtures. And then we also considered physical change and chemical change. We defined what physical change is, what chemical change is, and we also established the differences between them. Okay. All right. So at this junction, I will evaluate the class very shortly. But if you have questions on what I've treated so far, please feel free to put them in the comment section. I'll pick them up and then respond accordingly to them. Thank you very much. Now, let's quickly evaluate this lesson with these following questions. Now, can you explain the difference between a pure substance and a mixture? What are the differences between a pure substance and a mixture? So, if you know the answer, please type it into the comment section. What is important to know if a substance, why, sorry, pardon me, please, let's take that again. Why is it important to know if a substance is pure or a mixture? Why do we need to know? How do the properties of pure substances differ from those of mixtures? All these questions I'm asking, if you know the answer, please just drop them in the comment section and then I'll pick them up and then respond accordingly. If you eat a pure substance, what changes might you observe? So what changes do you observe when you eat a pure substance? Now, why do chemists need to use pure substances in experiments? And then can you think of an everyday example of a pure substance? How do you know it's a pure substance? Okay, so please react to those questions and attempt them. It will help you a lot, at least to know whether you understand the lesson or not. And I'll pick up the answers in the comment section and treat them accordingly. All right. We also have other questions, so you can still go through the slides and then pick up the questions and respond to them accordingly. Okay. Um, this OBJ question says, which of the following is a chemical change? Painting a wall blue, a bicycle rusting, ice cream melting, scratching a key across the desk, making a sandcastle. So if you know the answer, please put your option, the correct answer in the comment section. Okay. Thank you so very much for watching and this class and listening and being a part of this class. The next class, we are going to be looking at separation processes. So please make sure that you are available and you join the lesson so that you can actually benefit from the class. I hope you've learned something today. And please, if you have any question, don't hesitate to put them in the comment section. I'll see you in the next video. Take care.